Diesel fuel, the lifeblood of a Mack engine, flows through lines and other components similar to the way blood flows through our bodies. The heart of the injection system is the injection pump, a durable precision component that's often replaced unnecessarily. It's easy to fault such a vital and complex component, but you can be sure that your doctor isn't going to recommend a heart transplant and perform the operation without extensive testing. And when it comes to trucks, you shouldn't either. This video will help you understand and diagnose the fuel injection systems used in Mack trucks. In addition to reviewing basic fuel injection and emissions control principles, we'll cover injection pump timing, nozzle cleaning, and systematic fuel injection troubleshooting. The kind of troubleshooting that should prevent you from performing the truck equivalent of an unnecessary heart transplant. We'll begin at the heart of the matter with the basics of fuel injection. The injection pump incorporates a supply pump that sucks fuel through a suction line from the fuel tank, through the primary fuel filter, and into the pump inlet. Then it pushes fuel from its outlet through a low-pressure line to the secondary fuel filter and into the injection pump. The primary fuel filter traps large dirt particles and sediment that might damage the supply pump, while the secondary fuel filter provides very fine fuel filtration to trap particles that might damage the close-fitting parts in the injection pump and nozzles. Now let's take a closer look at the supply pump to see how it works. A typical unit contains an inlet and outlet valve and a spring-loaded plunger that rides on a lobe of the injection pump. The rotation of the lobe causes the plunger to move in and out. As it moves inward, one side of the plunger sucks fuel past the inlet valve, and the other end of the plunger pushes fuel through the outlet. When the plunger reverses direction, the fuel that was drawn in through the inlet valve is forced past the outlet valve. The cycle repeats itself when the plunger starts moving inward again. Once the fuel reaches the injection pump, it fills the fuel gallery, which contains a series of plunger and barrel assemblies, one assembly for each cylinder in the engine. The supply pump provides more fuel to the injection pump than is needed at any one time. This keeps the fuel gallery completely filled so that each plunger and barrel assembly has enough fuel for delivery to the cylinder when needed. Excess fuel flows out of the gallery through an overflow valve and then through a return line to the tank. The overflow valve contains a spring-loaded ball or valve. It regulates the fuel pressure in the pump gallery by bleeding off a controlled amount of fuel into the fuel return line. Inside the pump, each plunger is attached to a roller lifter that rides on a camshaft. The lifters are spring-loaded to keep them in contact with the cam lobes. Each lobe forces a plunger to move up and down inside its barrel. Both the plunger and barrel are specially machined and ground as a matched set. The barrel has two ports, called the inlet and spill ports, which are placed 180 degrees apart. The upper portion, or head, of the plunger is cut and recessed in a spiral design known as a double helix. Each spiral cut is separated from the other by a vertical slot. When a plunger is below the inlet and spill ports, fuel fills the barrel. As the plunger moves upward, it closes the ports and traps the fuel in the barrel. That's why this plunger position is called the port closing position. Further upward plunger movement pressurizes the trapped fuel, which unseats the delivery valve and sends the fuel into an injection line. The pressurized fuel in the line causes an injection nozzle to open and deliver fuel into the cylinder. Any fuel that leaks off inside the nozzle returns to the fuel tank through return lines or passages. Back at the injection pump, fuel flows past the delivery valve until the plunger opens the inlet and spill ports. This is known as the port opening position. Now, fuel pressure above the plunger drops and the delivery valve seats, stopping fuel flow to the injection nozzle. Fuel from the gallery constantly fills the areas above and below the head of the plunger as it cycles up and down. Take a break now to review what we've covered so far. The way the camshaft in the injection pump is ground determines the sequencing of the plungers and the length of their strokes. So, with the injection system we've just described, the plungers all deliver the same amount of fuel to the cylinders in a constantly repeating sequence. The constant sequence is okay because it follows the firing order of the engine. But different amounts of fuel must be delivered to the cylinders at different times to start and stop the engine, as well as vary its speed. This is done by rotating the plungers in their barrels and allowing the helixes on the plungers to change their effective strokes. The effective stroke is the distance between the port closing and port opening positions. Gear teeth or balls on the control rack operate control sleeves that attach to each plunger. As the rack moves in and out, all the plungers rotate equally. This action changes the amount of fuel that's pressurized and sent on to the injectors. For example, with a plunger turned to this position, its vertical slots line up with the ports in the barrel. This results in no fuel delivery, since fuel cannot be pressurized when the ports remain open through the full stroke of the plunger. As the plunger rotates from this position, the amount of fuel delivered to the cylinder depends upon the length of the helix that's aligned with the ports. Here is a low fuel delivery position. Notice the short effective stroke, which results in a small amount of fuel being injected into the cylinder. Here is a medium fuel delivery position. And here is the full fuel delivery position. The helix covers the ports for the greatest distance, resulting in the longest effective stroke and maximum fuel delivery. So far, we've looked at how a simple injection pump plunger operates. Typically, however, plungers have more complicated machining for calibration to a specific pump and engine combination. Often, a plunger has a recess on top called a retard slot. This recess usually retards injection timing about 8 to 10 degrees for cold start situations. Here's how it works. With the plunger in this position, the recess lines up with the spill port. As the plunger moves upward, it closes off the spill port later than normal, causing injection to occur later. This allows the piston to travel higher and generate more heat in the cylinder. The resulting higher cylinder temperatures make combustion easier during cold starts. Two types of emissions control systems, also called puff limiter systems, are currently used on Mack trucks. Both restrict fuel delivery under certain conditions by limiting the movement of the control rack. The first type contains a reversing relay mounted on the intake manifold and an air cylinder mounted on the front of the injection pump. With certain engine and transmission combinations, this system may also contain a torque limiting valve on the transmission. The reversing relay is supplied with chassis air pressure at its supply port. The parking brake valve vents the air pressure in this line when the parking brakes are applied. Intake manifold pressure acts on the relay at its signal port. The outlet port is connected to the air cylinder. Air pressure from the relay controls a spring-loaded piston and rod assembly in the air cylinder. It's called a reversing relay because the air pressure at the outlet port is actually the reverse of the pressure supplied by the intake manifold. For instance, when manifold boost pressure is low, as when a truck idles or pulls out from a full stop, the relay provides high outlet pressure to the air cylinder. A spring in the relay overcomes manifold pressure and pushes a pintle away from its seat. The resulting high outlet pressure from the relay causes the rod in the air cylinder to extend and limit the travel of the rack. This leans out the fuel-air mixture, lowers exhaust emissions, and reduces smoke output. As the turbocharger increases boost pressure, the reversing relay lowers the air pressure to the air cylinder. Now, manifold pressure overcomes spring pressure and forces the pintle closer to its seat. The lower outlet pressure which results allows the spring in the air cylinder to retract the rod for greater rack travel and greater fuel delivery. Take a break here to review. When equipped, the torque limiting valve receives manifold air pressure at a T between the intake manifold and the signal port on the reversing relay. The valve is designed to vent some of the signal pressure to the relay in certain high torque gear ranges, usually reverse or first and reverse. It vents pressure in order to fool the relay into thinking that the turbocharger is not developing enough manifold pressure to handle more fuel. This causes the spring in the relay to overcome the lower manifold pressure and push the pintle away from its seat. High outlet pressure from the relay now extends the rod in the air cylinder, thus limiting fuel delivery and preventing excessively high torque from damaging the drivetrain. The second type of emission system includes an LDA assembly and is used on mechanical, non-VMAC equipped Bosch P7100 injection pumps. The LDA is mounted on the back of the pump. It limits fuel delivery in the same way that the air cylinder in the reversing relay system does. In fact, you can think of it as a calibrated air cylinder, only instead of output pressure from a relay, this assembly works directly in response to manifold boost pressure. The LDA contains a spring-loaded diaphragm that's attached to an arm. The arm acts on a cam follower that controls the position of the control rack. When boost pressure is low, the spring pulls the arm back limiting the travel of the rack. But when boost pressure is high, the diaphragm pushes in on the spring, moves the arm in, and allows more rack travel and greater fuel delivery. There's also a fuel economy system called the Maximizer system that you should be aware of. It limits fuel delivery and governed RPM in top gear, and it's used only on Maxidyne engines equipped with American Bosch injection pumps. The system consists of a Maximizer dual-speed governor with an air cylinder and an air valve mounted on the cover of the transmission. The air valve is controlled by the top gear shift rail. In all gears except top gear, air pressure is routed through the air valve to the air cylinder assembly on the governor. Air pressure forces a piston and pin in the cylinder forward and allows the fulcrum lever, bracket, and control rack in the pump to move to the full throttle position. In top gear, however, the air valve vents the air pressure to the cylinder. The spring forces the piston and pin to pull back on the fulcrum lever and control rack. This reduces fuel delivery and increases fuel economy. That's how these systems operate. Now for diagnosis. To determine whether a reversing relay system is operating properly, do the following. With the truck running at idle, at operating temperature, and in neutral, apply the parking brakes and rev the engine. Dark smoke should come out of the exhaust. Then release the parking brakes and rev the engine again. This time, very little or no smoke should exhaust. If dark smoke continues to exhaust with the brakes released, the puff limiter system is malfunctioning. Begin diagnosis by removing the air cylinder and its air line from the engine. Apply 60 psi air pressure to the line. The air cylinder rod should extend fully, and neither the cylinder nor line should leak. Next, check the rod extension, or PLE adjustment. With air pressure still applied, measure the length of the rod to the machined surface on the cylinder at the base of the threads. Now, check the PLE number stamped on the pump. PLE stands for puff limiter extension. Subtract the PLE number from the first extension measurement to find the required thickness of shims. In this case, the shim pack should measure 93 thousandths. Place the correct shims on the cylinder and install it and the airline on the engine. Check the exhaust smoke again by revving the engine, with and without the parking brakes applied. If the smoke still does not vary, as described previously, continue diagnosis by testing the torque limiting valve if equipped. Disconnect the airline to the torque limiting valve at the T to the reversing relay. Apply 60 psi air pressure to the line. Then shift the transmission through its gears while you listen for air venting at the valve. Air pressure should vent at the valve in reverse or first and reverse. If it vents in any other gear range, replace the valve. If pressure does not vent, remove the air line at the valve and make sure it's not blocked. If the line is clear, replace the valve. Take a break now to review what we've just covered. Reversing relay testing was covered in MAC Service Bulletin number 46M004. We'll briefly cover those procedures next. Remove the relay from the engine. Attach two pressure gauges to the valve, one at the outlet port, the other at the signal port. The signal port gauge must also be connected to a pressure regulator. Both gauges must be accurate to within 1/10 psi in the 20 to 40 psi range. Connect a shop air line containing a shutoff valve and T to the supply port on the valve. Also connect an air line from the T in the supply line to the regulator. In case you missed some of the connections, here's a diagram of what this test setup looks like. Here are the gauges attached to the outlet and signal ports. The pressure regulator connects to the signal port gauge, and a T attaches the supply port on the relay to the pressure regulator and the shop air line containing the shutoff valve. To perform a test, do the following. Close the pressure regulator valve and slowly open the shutoff valve to apply 90 to 110 psi air pressure to the supply port. Adjust the pressure regulator to apply 5 psi pressure to the signal port. Now, note the pressure reading on the outlet port gauge and add the 5 psi signal port pressure to the reading. Compare this reading to the specification listed for the part number of the relay you're testing. If the pressure doesn't fall within specs, replace the relay and test the smoke output again. Testing the overall operation of the LDA system is very similar to the reversing relay tests, except you must apply 20 psi shop air to the LDA before revving the engine. Then you remove the pressure from the LDA and rev the engine again. Dark smoke should exhaust with pressure applied to the LDA, and little or no smoke should exhaust with the pressure removed. If your results differ, the LDA is malfunctioning. To find the problem, disconnect the LDA air line at the LDA and at the intake manifold, and check the line for leaks and restrictions. Next, connect an air line containing a shutoff valve and gauge to the LDA. Then apply 20 psi shop air to the unit. Listen for any leaks. If you hear none, close the shutoff valve and watch the gauge to see how much pressure bleeds down in 2 minutes. If any pressure drop occurs, the LDA must be repaired. Have the LDA serviced only by a certified injection pump shop. Do not attempt to repair or replace this device yourself. To test the operation of a maximizer system, check the no-load governed RPM in each gear range with the wheels blocked, the parking brakes applied, and the clutch released. The system is operating properly if the RPM lowers only in top gear and is the same in all other ranges. If the governed RPM is the same in every gear range, check the air supply to the governor. Air pressure should be available here in all ranges except top gear. If it is, the maximizer is malfunctioning and must be adjusted or repaired. If not, check the air valve and its air supply and outlet lines for blockage or damage. On the other hand, if the governed RPM lowers in top gear and any other gear, but is higher in at least one other range, replace the air valve. Be sure to test the system again after making any repairs. Take a break now for review. Correctly setting the injection pump timing is vitally important to obtaining optimum fuel economy, exhaust emissions, and engine durability. Its importance cannot be overemphasized. For instance, if the pump timing is too far advanced, injection occurs before the piston has risen high enough in the bore. This allows the fuel spray from the injector to ignite at the edges of the piston, or even in the ringlands, causing the piston to erode, burn, or break. On the other hand, if the pump timing is retarded too much, the piston rises too high in the bore before injection. This prevents the fuel from swirling in the bore properly, resulting in low power and increased exhaust emissions. Two pump timing methods exist: the high-pressure timing method and the fixed timing method. High-pressure timing is recommended for all Mack engines, except those with a Bosch P7100 or higher P model number injection pump. To properly set the timing this way, you must use a timer, such as the one shown here. We'll review all the steps for setting pump timing using a high-pressure timer. But remember that it's important to carefully follow the instructions in the appropriate Mack service manual. Also, there are two adjustments you must check first to set the pump timing correctly. First, check, and if necessary, adjust the puff limiter extension, as we covered earlier. And second, check the accuracy of the timing pointer and adjust it if needed. This is actually a simple process. Zero a dial indicator on the number 1 piston when it reaches its highest point. Turn the crankshaft counterclockwise until the piston moves downward 25 thousandths inches, or 0.64 millimeters, and mark the pointer position on the damper. Then turn the crankshaft clockwise until the piston again moves downward 25 thousandths inches, or 0.64 millimeters, and also mark this pointer position on the damper. The exact center between these two marks is TDC for the number 1 cylinder. Turn the crank counterclockwise past the center mark, then clockwise to align the pump pointer with the center mark, and if necessary, adjust the pointer to line up with the factory TDC mark on the crank damper. Prepare to attach the high-pressure timer to the engine by cleaning the number 1 cylinder fuel line connection and the fuel inlet and return line connections with compressed air or cleaning solvent. Then carefully remove and cap the number 1 injection line. Don't loosen the delivery valve while you're doing this, or a fuel leak will result. Remove the overflow valve. Then cap the outlet port on the pump. On older Robert Bosch pumps, be sure to cap both the overflow valve and inboard side return line outlets on the pump. Remove the fuel inlet line and attach the high-pressure line from the high-pressure timer to the inlet connection on the injection pump. Attach the timer's return line to the number 1 delivery valve. Secure the stop lever in the run position. On most engines, connect an air line with a regulator and gauge to the puff limiter air cylinder. Apply 30 psi air pressure to the cylinder. However, do not attach an air line or apply air pressure to the air cylinder on any 1990 E6 350 engine equipped with an AMBAC injection pump with part number 313GC-5187-P2 or -P4. The movement of the control rack on this engine and pump combination must not be limited in any way. Move the throttle lever back and forth several times. This is very important because it prevents the cold start feature of some pumps from affecting the pump timing. Then secure the throttle lever in the full load position. Now turn on the high-pressure timer to pressurize the fuel gallery in the pump. At this point, a solid stream of fluid should be visible coming from the nozzle on the timer. Slowly rotate the crankshaft clockwise to bring the number 1 piston near TDC on its compression stroke. Stop turning the crank just as the fluid flow at the timer nozzle changes from a solid stream to droplets. This is the port closing position. Check the pump pointer on the timing indicator. It should be aligned with the correct timing specification. If it's not, you'll have to adjust the position of the injection pump gear. Shut off the high-pressure timer. Remove the seal on the pump gear cover and remove the cover. Loosen the pump gear bolt slightly to allow the gear to move on the drive hub. Turn the pump cam counterclockwise until the gear bolts are at the ends of the adjusting slots. Then turn the crankshaft counterclockwise at least 45 degrees. Turn on the high-pressure timer and rotate the crank clockwise until the pump pointer is aligned with the proper timing specification on the damper. Next, slowly turn the injection pump drive clockwise until the fluid flow at the nozzle on the timer changes from a solid stream to droplets. With the injection pump drive and engine crankshaft in these positions, torque the pump gear bolts to specification. Check the timing by again turning the engine crankshaft counterclockwise at least 45 degrees, then clockwise until the solid stream of fluid turns into drops. The pump indicator should now align with the correct pump timing specification on the damper. Turn off the timer. Clean the gasket surfaces on the timing and pump gear covers. Install the gear cover using a new gasket. And after torquing the cover bolts, install a new seal wire and seal. Disconnect the air line to the pump limiter air cylinder and remove all the high-pressure timer connections and caps. Reinstall and torque the fuel lines and reconnect the air cylinder line. Also, reconnect the throttle and stop lever controls. That completes Part 1 of fuel injection. Part 2 begins with P7100 pump installation and timing. But for now, take a break to review these important points. Here in Part 2, we'll complete our review of injection pump timing and also cover fuel system diagnosis procedures, the correct methods for cleaning MAC fuel injection nozzles, and some service updates. The procedures for installing and timing a P7100 injection pump differ depending on whether the pump is strictly mechanical or is equipped for operation with the VMAC electronic control system. So we'll review the process for a VMAC pump first. When the pump and econovents have been removed from the engine, the first part to install is the econovents assembly. Remember, however, that it's not necessary to remove the econovents to take the pump off the engine. Start by thoroughly cleaning the gasket surfaces on the block and econovents. Install a new gasket on the assembly and position it in the block. Install the mounting bolts and torque them to specification in a cross pattern. Make sure the pump drive turns freely after all the bolts have been torqued. If the drive binds, loosen the mounting bolts. Check for clearance between the econovance pilot and the cylinder block pilot bore. If clearance exists here, inspect the pilot and bore for damage. Loosen the control valve mounting screws. Then retorque them to specification, followed by the econovance mounting bolts. Again, check the pump drive for binding. If the drive still binds, remove the adapter housing from the injection pump and install it on the econovance. Torque the pump mounting bolts to specification and check for binding again. At this point, if the pump drive still binds, replace the econovance assembly. If necessary, install the adapter housing on the injection pump. Also, if this one-piece Celeron pump drive ever needs to be replaced, be sure to install this all-metal design. Here's how. Use the proper special tool to hold the injection pump drive while removing its retaining nut. After removing the nut and washer, use a standard bar puller to remove the drive coupling from the shaft. Thoroughly degrease the tapered surfaces on the injection pump camshaft and drive hub using triethane or an equivalent degreasing agent. Failure to degrease the drive components before assembly may allow the drive hub to slip. Then install the metal inner hub on the shaft. Do not install a shaft key with the hub. Install the hub washer and retaining nut and hand tighten the nut. Install the snap ring inside the outer coupling as shown. Slide the outer coupling over the inner hub. Hold the coupling in place with a special tool and torque the hub retaining nut to 200 foot-pounds. Stamp the letter M on the adapter housing to indicate that the metal drive hub has been installed. Lube and install the O-ring in the connector to the injection pump. If equipped, install the jumper harness on the injection pump. This harness should be installed on any P7100 VMAC injection pump that doesn't have an integral harness whenever the pump is removed from the engine. Tighten the pump connector ring to the correct torque. Check the torque on this ring whenever a truck equipped with an injection pump jumper harness is in for service. Next, make sure the adapter and econovance gasket surfaces are clean. Then, with a new gasket installed on the adapter, slide the pump into position on the econovance. Assembling a pump with the metal drive assembly on the engine is easier if you install alignment pins first and place the outer coupling on the econovance mating gear. Put the pump in position and turn the econovance drive to engage the gears. Then slide the pump into place. Install and torque the pump mounting bolts to specification. The back of the VMAC injection pump also needs to be properly supported by following a specific sequence for the installation of the rear support brackets and links. The first step in this process is to install the lower rear injection pump support bracket on the cylinder block. Tighten the bracket mounting bolts until snug, and then loosen them 1/4 turn so the bracket moves freely from side to side. Install the upper rear support bracket on the pump in the same way. Install the 3 links between the mounting brackets. Torque the link mounting bolts to specification. Then torque the lower support bracket bolts on the cylinder block, followed by the upper bracket bolts. The pump is now properly installed on the engine. By the way, more recent VMAC pumps have support bracket arrangements that look like this or like this. Both of these arrangements should also be installed in the way we just described. To time a VMAC P7100 pump, first make sure that the timing pointer accurately indicates TDC. On newer E7 engines, a non-adjustable TDC pointer is now located in the bell housing below the flywheel. Before timing the pump, check to make sure the pointer is not bent. If it is, replace it. Remove the timing event marker from the back of the pump. Clean the bore threads of any oil, Loctite, or Celastic residue. And install the fixed timing probe from the position sensor. Connect the ground clamp from the sensor to a good engine ground and turn the sensor on. Now, using this hub rotation tool, turn the pump drive hub clockwise until both lights on the sensor light. The A lamp must light first, followed by the B lamp. Also, do not use the inner shaft nut to turn the hub. Improper pump timing will result. Use only the hub rotation tool because it bears on the hub exclusively and prevents the advanced features of the Econovance assembly from altering the static pump timing. Rotate the crankshaft until the number 6 cylinder is near TDC compression. This is very important. Be sure to time P7100 VMAC pumps to the number 6 cylinder. Next, turn the crank counterclockwise past the pump timing specification. Then, turn it clockwise to align the pointer with the specified timing mark. Align the bolt holes in the pump gear with those on the pump drive hub and install the gear. Lightly tighten the gear mounting bolts to allow movement between the gear and drive hub. Use this hub rotation tool to turn the pump hub counterclockwise until the mounting screws bottom in the slots in the gear. Again, rotate the hub clockwise until both lights on the position sensor light. Torque the gear mounting screws to specification. Take a break here to review. Check the timing setting by turning the crankshaft counterclockwise at least 45 degrees before TDC on the compression stroke of the number 6 cylinder. Turn the crank clockwise until both lights on the position sensor are lit, and note the amount of advance indicated by the timing pointer. If the timing is not within 1/4 of a degree of the specified mark, complete the timing procedure again. When the timing is correct, lubricate and install a new O-ring on the cover. Then install the cover on the engine and torque the cover bolts to specification. Remove the position sensor. Pre-lube the governor by adding 3 1/2 ounces of engine oil at the position sensor bore. Clean any oil residue from the timing event marker threads and its mating threads in the injection pump bore. Completely back off the jam nut on the timing event marker and put a 1/8 to 1/4 inch bead of silastic on the threads at the bottom of the jam nut. Install the timing marker and hand tighten it until it's seated in the housing. Run the jam nut down until it contacts the housing. Then torque the jam nut to specification. Also, remove this plug on the injection pump. And pre-lube the pump with 12 ounces of engine oil. Reinstall and torque the plug to the proper specification. Now we'll review the differences you need to know when installing and timing a mechanical non-VMAC P7100 pump. Since there's no Econovance assembly to worry about, pump installation is straightforward. Torque the pump drive hub using the proper holder. Then, with a new O-ring installed and lubed, slide the pump into place and bolt it directly to the engine. As for timing, it's exactly the same as the VMAC procedure with these important exceptions. To install the position sensor, remove this plug from the back of the pump. Clip the ground clamp to a good ground and screw the sensor probe into the threaded bore. Next, turn the drive hub nut on the pump until both indicators on the sensor light in the proper sequence. A first, then B. A special hub rotation tool isn't required. Rotate the crankshaft until the number 1 cylinder is at the top of its compression stroke. This is very important. Time all mechanical non-VMAC P7100 pumps to the number 1 cylinder. Turn the crank counterclockwise past the pump timing spec on the damper, then clockwise to align the pump pointer with the specified timing mark on the damper. And bolt the pump-driven gear into place. Remember, all mechanical non-VMAC P7100 pumps must be timed to the number 1 cylinder, not number 6. Finally, don't forget to check the pump timing before disconnecting the sensor, pre-lubing the governor with 12 ounces of engine oil, and reinstalling the sensor bore plug and the pump-driven gear cover. Also, pre-lube the injection pump with 12 ounces of engine oil before starting the engine. Reinstall and torque the pump lube plug to the proper specification. Take a break now to review what we've just covered. Whenever a poor starting, excessive smoke, low power, rough idle, or other performance complaint leads you to suspect the fuel system as the source of the problem, you should isolate the cause by following a systematic troubleshooting procedure. We're going to review a complete series of checks organized in order of most likely to least likely causes, but note that you may not have to do them all. Just road test the truck after making any needed adjustment or repair. Continue troubleshooting only if the performance problem still exists. To get started, first check for full travel of the operating lever on the injection pump. The lever should contact the high idle stop, and then the spring-loaded portion should break away for a distance. If the lever doesn't contact the stop or break away, adjust the throttle linkage. Also, make sure the lever return linkage on the engine doesn't bind. Also, check the shutoff lever to be sure it extends to the full open fuel position. If any forward travel exists with the lever in the open position, adjust the cable to remove it. Check the fuel tanks to be sure they're not empty. And inspect a sample of the fuel to be sure it's clean and not contaminated with dirt, wax, or bacteria. Install a pressure gauge and clear line between the injection pump's fuel gallery inlet and the secondary fuel filter outlet. After bleeding the gauge and lines, start the engine and look for bubbles in the fuel. If bubbles appear, a leak exists somewhere in the system between the clear line and the fuel tanks. Check all hoses, connections, and plugs from the clear line back to the fuel tanks to find the leak. Then measure the fuel pressure according to the procedure listed in the appropriate service manual. If the pressure is not within specification, a restriction probably exists in the suction, pressure, or return lines. When you're examining components for restrictions or leaks, be sure to look for the following conditions. Check the fuel tank vent system for blockage. To do this, inspect the vent tubes or check the operation of the vent valves in the fuel tank caps. Inspect each fuel tank stay pipe for cracks or blockage. On fuel tanks with vent tubes, examine the check ball in the vent tube fitting. The ball should rattle freely in the fitting. Remove the fuel crossover line and check it for blockage. Inspect both the secondary and primary fuel filter mount castings for cracks and leakage. And make sure the pipe plugs on the primary filter casting are tight and not leaking. Check for fuel leaks on the pressure side of the fuel supply pump. And carefully examine the nozzle fuel tubes for kinks, blockage, or other damage. Next, inspect the rubber fuel supply and return lines for internal blockage. One good check to make here is to blow air through each end of a line. If the air doesn't pass through both ends freely, a rubber flapper inside the line is probably restricting the flow. Replace the line. Take a break now to review what we've just covered. If none of the previous actions brings the fuel pressure within specification, continue troubleshooting by priming new fuel filters and installing them. Disassemble and inspect the overflow valve assembly. The housing, spring, and valve must not be nicked, corroded, or damaged in any way. Also, on older style supply pumps, remove the caps and inspect the plungers, springs, and housing bores. Again, these parts must not be damaged in any way. With newer, sealed supply pumps, check the fuel pressure again. If it is not within specification, replace the supply pump. If your initial fuel pressure reading was within specifications and you did not find any leaks, or you made repairs to the fuel system, but a performance problem still exists, continue troubleshooting with the following tests. Check and if needed, adjust the no-load high idle speed according to the procedures in the proper service manual. Be sure to reinstall the tamper-resistant shield and seal after adjusting the speed to specification. Inspect the operation of the puff limiter system, as we covered earlier. Adjust the air cylinder shims or have the LDA repaired or replaced if necessary. If equipped, also check the operation of the maximizer system. Repair the air supply to the governor or have the maximizer air cylinder adjusted or repaired as necessary. Measure the size of the injection line holes at both the nozzle and injection pump ends. If these lines were tightened too much, fuel flow to the nozzles will be restricted. Replace any blocked or damaged lines. Pop test the injection nozzles. Each nozzle must open at the specified pressure, atomize the fuel in the proper spray pattern, and not leak. If testing shows a malfunctioning injector, it should be disassembled, cleaned, and tested again to determine whether it needs to be replaced. We'll cover the latest details on cleaning Mack injection nozzles later in this video. Next, check the timing indicator alignment and injection pump timing as described earlier. At this point, if a problem still exists, see the appropriate Mack service publications for further information on checking the induction system and the turbocharger. And always check the engine compression, valve timing, and valve lash before replacing or recalibrating the injection pump. Next, we'll review the troubleshooting procedures for a no-start condition. With this problem, first check whether the fuel system is properly primed with fuel by cracking the line on the pressure side of the supply pump and cranking the engine. Fuel should be pumped out of the connection. If it isn't, check that the supply pump is capable of delivering some fuel. To do this, remove the connections on both sides of the pump and attach lengths of line to both connections. Then prime the suction line with fuel and submerge the end of the line in clean fuel in a separate container. Hold the pressure line over an empty container. Then crank the engine and note the fuel flow through the pump and into the empty container. If no fuel flows, repair or replace the supply pump. If fuel does flow, reconnect the lines and prime the fuel system. Then perform all tests possible from the first troubleshooting procedure we reviewed. In particular, check for suction and pressure side leaks, fuel line restrictions, clogged fuel filters, and a damaged overflow valve assembly. To complete your troubleshooting after you get the engine started and running, test for suction leaks and check the fuel pressure. Take a break now to review what we've just covered. Injection nozzles can be cleaned in two ways. Manually, using brass cleaning brushes, brass wire wheels, and pins, or electronically, using an ultrasonic cleaner. To clean an injection nozzle manually, use the proper brass brush or brass wire wheel to remove any foreign material from the outside of the nozzle holder and nozzle. Be sure to clean any carbon residue from the nozzle tip, nozzle body and nozzle nut. Place the nozzle holder in the proper fixture and loosen the nozzle nut 1/8 of a turn. Next, to prevent shearing the dowels in the nozzle holder, relieve the spring pressure on the nozzle tip by clamping the tip to the nozzle body. Then loosen the nozzle nut until it can be removed by hand. This process prevents spring pressure from damaging the nozzle nut threads and contaminating the nozzle holder with metal chips. Disassemble each nozzle completely. Keep all parts for each assembly together. Do not mix them up with the parts for another nozzle. Also, when handling the individual nozzle parts, be sure to hold the needle valve by the stem only. Do not touch the finely lapped areas on the valve. The oils from your skin will damage these surfaces. Clean the outside of the nozzle tip with the proper brass brush or brass wire wheel. Be sure to remove any carbon buildup from the nozzle tip and the flat clamping surface on the body of the tip. Clean the nozzle nut and threads with a steel wire brush to remove all carbon and combustion deposits. Do not use the steel brush, emery paper, or a metal scraper to clean any other parts of the nozzle assembly. Clean the spray holes in the nozzle tip with the correct cleaning needle. Remove any combustion deposits in the nozzle tip with a commercially available cleaner. And dry the part using moisture-free compressed air. Also use combustion cleaner to remove any deposits from the needle valve. Do not use a wire wheel or scraper of any kind to clean the needle valve. Clean all remaining parts with the brass brush or brass wire wheel. Rinse all nozzle parts in clean solvent to remove all dirt and carbon residue. Blow all parts dry and coat them with clean test oil before thoroughly inspecting them. Any part that is cracked, pitted, scraped, corroded, bent, scuffed, excessively worn, or overheated must be replaced. In particular, carefully inspect the nozzle tip, the clamping area on the body of the nozzle tip, the needle valve seat, and the needle valve body for damage or excessive wear. If you're going to replace a nozzle tip assembly, be sure to clean the new replacement parts in solvent first. This removes a protective coating that may affect nozzle operation. Also, slide test a new or used nozzle before reassembly. To do this, dry the parts with compressed air and lubricate them with clean test oil. Insert the needle valve fully into the nozzle tip. Hold the assembly at a 45-degree angle. Then pull the needle valve 1/3 of the way out of the nozzle tip and release the valve. The valve should slide all the way back into the nozzle tip under its own weight. If it doesn't, clean both parts again and retest them. If the assembly still fails the test, replace both the needle valve and nozzle tip. Take a break here to review. When reassembling an injection nozzle, work in as clean an area as possible. Rinse each part with clean test oil to remove any particles, and reassemble the nozzle in the reverse order of disassembly. Lubricate the clamping surface on the nozzle tip with a pressure grease. Then thread the nozzle nut onto the holder body for several turns and stop. Again, relieve the spring pressure on the nozzle tip by clamping it to the nozzle body. Tighten the nozzle nut until it's snug. Do not tighten the nut fully. When you feel the turning resistance increase substantially, remove the nozzle from the clamping tool and install it in the proper fixture. Then, torque the nozzle nut to specification. Test the nozzle and adjust the opening pressure if necessary. Also, check the nozzle for leakage and proper spray pattern before installing it in the engine. The ultrasonic cleaning process is the same as the manual cleaning process with these exceptions. There's no need to use a wire brush or wheel. Simply disassemble the nozzles as previously described and keep the parts for each nozzle separate from the others. Prepare the ultrasonic cleaning solution by following the directions that come with the cleaning material. This usually involves combining specific amounts of a cleaning powder and hot or cold water and stirring them until they're thoroughly mixed. Fill the cleaning tank with the solution to within a couple of inches of the top of the tank. Plug the unit in and turn the power and heat on. Allow the cleaner to run for at least 5 minutes so that the cleaning solution can degas. Then position the nozzle parts on the stainless steel holding tray and lower the tray into the tank. Do not place any parts directly on the bottom of the cleaning tank. Add or remove cleaning solution as necessary to keep the tank filled to within 1 inch of the top. Place the vented cover over the tank while the cleaner is operating. Turn off the unit and remove the nozzle parts when they're clean. 15 to 30 minutes is usually enough cleaning time. Then rinse the parts in clean solvent to remove any dirt particles. Be sure to refer to the proper Mack engine overhaul manual and the instructions provided with the cleaner for more detailed information. Lubricate, inspect, assemble, and test the nozzles as shown previously in the manual cleaning segment. As you've seen, Mack fuel systems are not that complicated. And remember, the one component that's the most complex, the injection pump, is often the least likely to be causing a performance complaint. That's why it's important to understand the information we've presented here about the basics of fuel injection and the correct pump timing, troubleshooting, and cleaning procedures. That way, the next time a fuel system gives you trouble, you'll know the best way to get to the heart of the trouble and repair it quickly. Take a moment here for review. The final part of this tape covers a series of fuel system-related service updates, including the installation of an Econovance improvement package, a new Econovance oil supply hose, and a new engine harness connector for the Econovance jumper harness. We'll also review the proper inspection and repair of the delivery valve holders and gaskets used in Bosch P7100 injection pumps. We'll start with the Econovance Improvement Package. An important part of this package is a stiffer Econovance sleeve return spring, which should be installed on certain 1990 to 1991 E7 VMAC engines with serial numbers up to and including those beginning with 1W. Install the spring when you remove the injection pump from one of these engines only if there is not an S after the number stamped on the Econovance housing. If the S is there, or the E7 engine has a serial number beginning with 1X or up, the new spring has already been installed. Here's how to install the spring. Remove the control valve mounting screws and carefully lift off the control valve. Without disturbing the metal filter screen, remove the control valve gasket. Remove the upper 90-degree oil line fitting from the Econovance housing. And install the new 90-degree fitting from the package. Clamp the scalloped drive hub on the Econovance in a soft-jawed vise and remove the drive hub bolt and washer. Hold the spline sleeve assembly in the housing while removing the bolt and washer. Remove the sleeve assembly from the rear of the housing. Then lift the inner sleeve off the shaft. Remove the old Econovance spring. Thoroughly clean the inner sleeve and shaft with solvent and dry these parts with compressed air. Use clean engine oil to lubricate all of the gear surfaces. With its grooved side up, install the drive hub washer on its bolt. Then coat the threads of the drive hub bolt with Loctite 242 or an equivalent. Install the new Econovance spring and inner sleeve on the shaft. Make sure the spring is properly seated by pushing down on the inner sleeve until it's flush with the seat. If the sleeve won't contact the seat, reposition the spring before continuing. Reinstall the spline sleeve assembly in the housing and install the drive hub bolt and washer. Torque the bolt to specification. Install the new control valve mounting gasket on the Econovance. The location of this gasket is extremely important, so be sure to position it properly. Reinstall the control valve and torque its mounting screws to specification in a cross pattern. To indicate that the Econovance now has the updated spring, stamp an S after the Econovance serial number located on the housing. Then install it on the engine as described previously. Also, be sure to properly reprogram the VMAC module after the spring is installed. Check the oil supply hose to the Econovance to be sure the latest type's installed. This is what it looks like. The hose connects to the main oil gallery through an elbow at the front of the engine and to the Econovance through another elbow. This design replaces all previous oil supply hose arrangements. So be sure to install it and plug any of the previous oil outlets whenever you update an Econovance with the new spring, service a previous version oil line, or replace the rear pump support brackets. Also, any VMAC injection pump equipped with an integral harness or a jumper harness must have the proper mating connector installed on the engine harness. Here's how to install this harness connector in place of one that's designed to attach directly to the injection pump. First, use WD-40 or an equivalent to clean all the wire insulation within 6 inches from the rear of the existing pump connector. Be sure to use a cleaner that will not remove the ID codes from the wire insulation. Cut the cleaned wires approximately 1 inch behind the 7-pin injection pump connector and discard the connector. Strip approximately 1/4 inch of insulation from the end of each of the wires. Clean the stripped wire ends with an electrical contact cleaner and blow them dry with compressed air. Install the correct terminal on the end of each wire. To install the 14 gauge or 2 millimeter terminals, set the crimp tool to the proper gauge. And adjust the contact depth so that the end of the terminal is 1/32 of an inch above the indenters. Place one of the 14 gauge stripped wire ends in the terminal and fully depress the tool handles. Remove the terminal from the tool and inspect it for a correct and secure crimp. Crimp the terminal onto the other 14 gauge wire in the same way. Then reset the tool for the 16 gauge wires. And crimp the terminals onto the remaining wires following the same procedures. Determine the correct locations for the terminals in the connector by referring to the proper MAC service publication. Slide the Deutsch strain relief connector ring onto the harness. Then push the terminals into the proper cavities in the female side of the connector. Check each terminal for proper seating by pulling lightly on the wire to make sure the terminal won't back out of the connector. Clean the Deutsch connector and connector ring threads with Loctite Primer T or an equivalent. Allow the primer to dry for about 5 minutes. Coat the threads of the Deutsch connector with Loctite 242 or an equivalent and screw the strain relief connector ring onto the connector. Secure the strain relief ring to the wires with a plastic tie wrap. To make the proper connections on the truck, install the jumper harness bracket on the engine as shown. Connect the engine harness to the jumper harness by aligning the notches in the connectors, pushing them together, and turning the lock ring clockwise until it clicks into place. Secure the body of the connector in the spring clips. To complete the installation, secure the connector to the bracket using a large tie wrap. The last update we'll review involves the delivery valve holders and gaskets used in Bosch P7100 injection pumps. If these holders or gaskets are worn or cracked, they could be causing an engine miss or skip in one or more cylinders. Here's how to inspect and perhaps repair the condition before replacing or recalibrating the injection pump. Remove the delivery valve holder assemblies from the pump and check them for excessive wear, cracks, or breakage. In addition, measure the width of the sealing surface on each holder and check it for cracks or erosion. If the width exceeds 1.2 millimeters or any cracks or erosion exist, replace the affected holder. Remove the delivery valve body and gasket and inspect the body surface for cracks or signs of leakage or excessive wear. The seats may be lapped lightly to remove minor wear or gasket material. But if light lapping won't remove the imperfections, the body and delivery valve must be replaced. In addition, if any one gasket is damaged, replace all of the delivery valve gaskets in the pump. To reinstall the delivery valve holder assembly, clean the body with solvent and dry it with compressed air. Then install a new gasket on the body. Do not use grease or lube of any kind to hold the gasket in place. Install the body and valve in the pump, followed by the spring, and, if equipped, any fill pieces. Using a drop of 90-weight gear oil, lubricate the O-ring, threads, and bottom surface of the delivery valve holder. Then install the holder in the pump. Torque the holder to 30 foot-pounds. Then, in one continuous motion, torque the holder to 89 foot-pounds. That wraps up this video on fuel injection. Take a moment here to review these important points from the final part of this tape.